Hello everyone. In this video, we will continue talking about false position method. We will talk about the halting condition of the false position method, and then I will give you an example about how to use this method to find the root of an equation. So there are two halting conditions. The first one is that FC is equal to 0. If that happens, which means that the intersection point C happens to be the root, then we can stop the iteration process. The second condition is that we halt if both of the following conditions are met. So there are condition A and condition B. Both of them should be satisfied, and then we can halt the iteration process. Condition A is that the step size is sufficiently small, which means the variable step should be less than a constant, and this constant is called epsilon step. And this means, remember that we define step as how much the interval is shrinked after each iteration, right? If at some point the interval is barely shrinked, which means the interval is already small enough, then there is no point to continue to do the iteration. And condition B is that the function evaluated at one of the endpoint should be sufficiently small. So we have the absolute value of FA is less than a constant, which is epsilon ABS, or the absolute value of FB is less than epsilon ABS. If we call this condition B1, and this is condition B2, then the second condition is condition A and condition B, and condition B is B1 or B2, right? So this is very similar to the halting condition of the bisection method. The only difference is that instead of use the width of the interval, we here use the step size. Okay, so if we halt due to the first condition, then the intersection point C is the root. If we halt due to the second condition, we choose either A or B as the root, depending on which one is a better approximation of the root. If the absolute value of FA is less than the absolute value of FB, we use A as the root. If the absolute value of FA is larger than the absolute value of FB, then we use B as the root. Okay. So here is one example. Consider finding the root of fx, which is equal to x squared minus 3. We start with the interval from 1 to 2, and we assume that the epsilon step is equal to epsilon ABS, and both of them are equal to 0.01. Remember that this is the same question we used as the example 1 in bisection method. By using bisection method, we did 7 iterations before we reach a good approximation of the root. So let's see how many iterations we need to do by using this false position method. All right, so for each iteration, we have A, B, FA, FB, C, and this C is equal to, use the formula, FAFB minus BFA over FB minus FA, and then evaluate the function value at C, and then we need to update the endpoint A or B, right? And then we need to calculate the step size. So since we start from the interval 1 to 2, so initially in the first iteration, A is 1, B is 2. So FA is 1 squared minus 3, which is negative 2. And B is 2 squared minus 3, which is positive 1. And C will be equal to A 1 times FB minus B times FA, which is 2 times negative 2, right? And then FB, which is 1 minus FA minus negative 2, right? So this will be equal to 5 over 3, which is 1.6667. So let's evaluate what's FC, which is 1.6667 square minus 3, right? So at this point, it should be negative 0.2221, right? So FC is negative, FB is positive, FA is negative. So FC and FB have opposite signs, which is the third scenario, right? Then we need to assign the value of C to the variable A, and the step will be defined as C minus A, right? C minus A is 1.6667 minus 1, so it's 0.6667. All right. So in the next, this is the first iteration. In the next iteration, we use A, which is already updated. So this should be 1.6667. B is the same, remains the same. And FA will be the old FC, so it's negative 0.2221. And FB remains the same, 1.0, right? So C will be A 1.6667 times FB, which is 1, minus B times FA, negative 0.2221, over FB, which is 1, minus negative 0.2221, right? So if you calculate this one, it should be 1.7273, okay? So 1.7273 square minus 3, this should be negative, so this FC should be negative 0.0164. And FC is negative, right? And FB is positive, FA is negative. So we are still in the third scenario. So we need to update the variable C by assigning it the value of C. We need to update the variable A, right? So the step size will be again C minus A. So C should be 1.7273 minus 1.6667. So this will be 0.0606. All right, this is the second iteration. So in the next iteration, A is updated by C, so it's 1.7273. B remains the same. So FC will be negative 0.0164 and FB will be 1.0. And this one will be A times FB minus B times FA, and over FB minus FA. Okay, so this should be 1.7317. Okay, 1.7317 square minus 3. So this should be negative 0.0012. Negative 0.0012. Okay, so you can see FC is again negative, FB is again positive, FA is again negative. So we are still in the third scenario. So A equal to C and step equal to C minus A, which is 1.7317 minus 1.7273, right? So this will be 0.0044. All right. So in the next iteration, A is updated by 1.7317. B will be the same. And this value will be negative 0.0012, right? And FB is the same. Okay, so you can see here, this step here is already 0.0044, so which is less than 0.01, right? And at this point, FA, which is negative 0.0012, this also less than 0.01, right? And the epsilon value is 0.01. So if you in the fourth, so 1, 2, 3, 4, when we reach the fourth iteration, we have the absolute value of FA less than epsilon ABS. And also this step, although we didn't calculate it, but we know that this should be smaller after each iteration. So it's definitely less than 0.01, because in the third iteration, the step is already less than this value, right? So which means in the fourth iteration, right, we got the root. After 4 iterations, we have the approximate value of the root. So the root is, because the absolute value of FB is 1 and the absolute value of FA is negative 0.0012. So A is a much better approximation of the root, right? So it's 1.7317. All right. Remember that we use 7 iteration in bisection method to reach the root, and by using false position, we use only 4 iterations. But it really depends. Sometimes false position is much slower than the bisection, and sometimes bisection is much faster than, sometimes bisection is much slower. So it really depends on the function and the initial interval. So there is no guarantee that one is faster than the other. So in the next video, we will talk about how to use MATLAB to implement false position method, and how to visualize, by using MATLAB, how to visualize the process.